Your Ford rolled off the assembly line with factory settings specifically engineered to pass federal EPA emissions and fuel economy tests, not to survive 200,000 miles in your driveway. Most owners believe that leaving their truck or SUV on its default factory settings is the safest way to protect their investment. But after spending over 15 years tearing down fried EcoBoost engines and replacing prematurely worn components, I can tell you that the factory configuration is quietly destroying your vehicle. Manufacturers design these vehicles to clear the warranty period with minimal overhead while hitting strict regulatory benchmarks, and the collateral damage is paid entirely out of your pocket once the odometer crosses 60,000 miles. Today, I am exposing 5 factory settings and built-in electronic features that are actively damaging your Ford without you ever knowing it. Setting number 3 forces your oil pump to run at dangerously low pressure during critical engine operating windows, starving your main bearings for protection. And setting number 1 is so deceptive that millions of truck owners actually think it is preserving their engine when it is doing the exact opposite, cooking critical components and setting you up for a $4,000 repair bill before your vehicle even turns 7 years old. Let's get into it. Setting number 5. The factory auto start-stop system defaulted to active on every single key cycle. Ford markets this feature as a seamless way to save fuel and cut tailpipe emissions at red lights, claiming it has no impact on long-term mechanical durability because they installed heavy-duty starters and AGM batteries. But here's what Ford does not tell you about basic internal engine fluid dynamics. When your engine is running at normal operating temperature, a micro-thin hydraulic film of engine oil, roughly 0.001 to 0.0015 inches thick, separates the rotating steel crankshaft journals from the softer aluminum, lead, or copper alloy main bearings. This hydrodynamic wedge of oil relies entirely on constant engine rotation and positive oil pump pressure to prevent metal-to-metal contact. The exact instant that factory auto start-stop shuts your engine off at a traffic light, that positive oil pressure drops from 25 pounds per square inch straight to 0 in less than half a second. While your vehicle sits at the light, extreme ambient engine heat causes that microscopic oil film to squeeze out from between the crankshaft and the bearing shells under the static weight of the rotating assembly. When the light turns green and you lift your foot off the brake, the starter motor violently cranks the engine back to life. For the first 2 to 3 complete crankshaft rotations, those bearings experience boundary lubrication, meaning raw metal is wiping directly against raw metal before the mechanical oil pump can prime the galleys and re-establish a pressurized hydraulic wedge. Now, consider the sheer math of daily driving. In a standard vehicle, without this setting enabled, your engine experiences 1 cold start when you leave for work and 1 start when you drive home. Over a 100,000-mile lifespan, that equals roughly 5,000 start-stop cycles. With Ford's factory auto start-stop setting permanently engaged, that same engine suffers anywhere from 50,000 to 120,000 restart cycles over that exact same mileage. I have pulled oil samples from EcoBoost engines with 75,000 miles that were subjected to constant stop-start driving, and the lab reports consistently show elevated levels of copper, lead, and tin, the exact sacrificial metallics that make up your crankshaft thrust washers and main bearing liners. You are literally grinding your upper rod bearings and thrust surfaces to dust every time you sit in heavy traffic, all to save roughly 3 tablespoons of gasoline per tank. Furthermore, this rapid cycle creates catastrophic thermal shocking on your turbochargers. When you bring your vehicle to a sudden stop after climbing a hill or pulling off a fast highway off-ramp, your turbo compressor housing is radiating heat well past 1,200 degrees Fahrenheit. The factory auto start-stop setting does not care how hot your turbo is. It instantly kills the ignition the moment the wheel speed hits 0. The coolant pump stops, the oil flow halts, and the static oil remaining inside the turbo center housing seal instantly bakes into solid carbon grit. The fix for setting number 5 requires 0 expensive tools, but it demands absolute discipline. Get into the habit of pressing the Auto Start Stop Disable button on your center console every single time you push the engine start button. Make it an automatic muscle memory movement. Key on, start stop off. If you do not want to press a button every time you drive, purchase a simple plug-and-play Auto Start Stop Eliminator harness that installs behind your dash switch in 5 minutes. It safely remembers your preference to keep the setting turned off permanently without throwing a single diagnostic code or altering your factory ECU programming. Setting number 4 is one that Ford markets as an advanced, worry-free maintenance convenience. But under real-world driving conditions, it creates the exact environment that destroys your engine timing components. The Factory Intelligent Oil Life Monitor algorithms. Ford advertises that you can safely rely on your vehicle's onboard computer to tell you when it is time for an oil change, with the dashboard monitor routinely allowing drivers to stretch intervals out to 10,000 miles or even 12,000 miles between services. Ford claims this algorithm uses complex mathematical modeling based on engine revs, ambient temperatures, and trip lengths to calculate real-time oil degradation. Here is the mechanical reality that I see on the lift every single week. The algorithm inside your instrument cluster counts engine revolutions and calculates theoretical fuel dilution, but it has no physical sensor inside the oil pan to measure actual shear viscosity, soot loading, or chemical oxidation. EcoBoost engines are direct injection, turbocharged powerhouses. Direct injection naturally sprays high-pressure fuel directly into the combustion chamber at up to 2,900 pounds per square inch. During short trips, cold ambient operation, or extended idle periods, unburned raw gasoline washes past the piston rings and dumps straight into your engine oil crankcase. When you allow the factory setting to dictate a 10,000-mile service window, that oil becomes heavily contaminated with raw fuel, dropping a 5W30 viscosity oil down to the equivalent of an 0W10 or 0W15 fluid. At that thinned-out viscosity, the oil completely loses its shear strength under the immense mechanical stress generated by the dual overhead camshafts and high-pressure fuel pump lobes. Even worse, the microscopic soot particles generated by direct combustion act as an abrasive slurry. This abrasive fluid circulates directly through your hydraulic timing chain tensioners and variable camshaft timing actuators. I have personally inspected timing chains on 3.5L and 2.7L EcoBoost engines that stretched over half an inch long at just 70,000 miles. Why? Because the owner dutifully followed the factory oil life monitor down to 5% remaining life, believing they were properly maintaining their truck. That stretched chain eventually slaps against the plastic guides, shattering them into pieces that fall down into the oil pickup tube screen, starving the engine of oil and causing total internal failure. A job that could have been completely avoided with timely maintenance suddenly becomes a $3,500 front engine timing teardown. What you should do instead is completely ignore the factory maintenance percentage on your instrument cluster display. Reset the monitor at every service, but never let your vehicle dictate the interval. Throw out the 10,000-mile recommendation entirely. Change your engine oil and filter every 4,000 to 5,000 miles maximum if you drive under normal conditions, and drop that interval to 3,000 to 3,500 miles if you tow trailers, idle extensively, or live in extreme cold or hot climates. Always demand a full synthetic oil that meets Ford's rigorous WSS-M2C 961-A1 specification, paired with a high-efficiency OEM filter containing a silicone anti-drainback valve. Spending $50 on an extra oil change twice a year is the cheapest insurance policy you will ever buy for a turbocharged engine. Now that we have covered how default stop-start cycles and extended service monitors silently destroy your engine's physical foundations, we have to look directly at the electronic control modules that actively manipulate fluid pressures and fuel delivery while you drive. Setting number 3 and setting number 2 represent two of the most insidious factory calibrations ever written into a Ford powertrain control module. Setting number 3, the factory two-stage variable displacement oil pump calibration programmed into your engine control unit. Ford engineered this variable displacement system to reduce parasitic mechanical drag on the crankshaft, advertising it as an advanced efficiency feature that improves overall fuel economy by fractions of a mile per gallon. The factory ECU is programmed to keep the oil pump in its default low-pressure mode across almost the entirety of your daily driving envelope. Under normal operating conditions, anything under roughly 3,000 revolutions per minute and moderate engine load, the computer commands a solenoid inside the oil pump to bypass output volume, artificially capping your engine's oil pressure at a meager 15 to 22 psi, even when the oil is piping hot. Here is the mechanical disaster taking place inside your block while that setting is active. Modern EcoBoost engines do not just use oil to lubricate bearings. They use pressurized engine oil as a hydraulic fluid to control the variable camshaft timing, VCT phasers, actuate the hydraulic chain tensioners, and spray cooling jets directly onto the undersides of the hot pistons. When you are cruising down the highway at 2,000 revolutions per minute on a hot summer afternoon, your engine oil temperature can easily climb past 230 degrees Fahrenheit. At that extreme temperature, thin 5W30 synthetic oil loses significantly more viscosity. Combined with the ECU's restriction holding system pressure down around 18 psi, the volume of oil reaching the furthest lubricated points in the engine, specifically the cylinder heads and turbocharger supply lines, drops to dangerous levels. The hydraulic VCT phasers on the end of your camshafts require consistent, high-pressure oil volume to maintain their precise mechanical position against the force of the valve springs. When low oil pressure mode starves those phasers, internal locking pins begin to chatter violently inside their housings. Over time, this mechanical chattering wallows out the soft aluminum housing of the phaser. The result is that infamous, violent metallic rattle you hear on a cold start that sounds like a coffee can full of bolts being shaken inside your engine bay. More critically, reduced oil pressure lowers the volume spraying from the piston cooling jets. Without that direct thermal relief, piston crown temperatures spike, leading to thermal expansion that scuffs the piston skirts against the cylinder walls, micro-welding the piston rings into their grooves, and causing severe cylinder wall scoring. I have personally pulled rod bearings out of 3.5L EcoBoost engines that showed clear signs of localized starvation and heat discoloration, not because the engine was low on oil, but because the factory setting refused to demand full oil pressure when the engine needed it most. The solution to setting number 3 is taking direct control of your engine's operating parameters through smart driving habits and proper maintenance modifications. While you cannot simply toggle a switch on the dashboard to override the ECU's variable oil pump solenoid, you can force the computer out of low pressure mode when mechanical stress is high. First, whenever you are towing, carrying heavy cargo, or driving in steep mountainous terrain, always lock the transmission out of high overdrive gears or select sport mode. Raising your engine RPM slightly above 3000 RPM instantly forces the ECU to energize the oil pump solenoid, switching the system into high-pressure mode and pumping 45 to 65 pounds per square inch of protective oil volume through the entire engine block. Second, strictly avoid ultra-thin oil viscosities if you operate in hot climates. Using a high-quality full synthetic oil with exceptional high-temperature, high-shear (HTHS) resistance prevents fluid thinning when the pump is trapped in low-pressure mode. Setting number 2 is one that Ford markets as a driver comfort feature, designed to make turbo delivery feel refined, but under real-world acceleration, it creates extreme thermal stress on your exhaust components. The aggressive electronic boost dump and soft throttle closure torque management strategies. Ford calibrates the Powertrain Control Module, PCM, to electronically smooth out engine torque delivery, preventing the abrupt, aggressive surge of boost that turbocharged engines naturally produce. When you press down on the accelerator pedal, the factory software does not simply open the throttle body and let the turbos spool freely. It continuously manipulates the electronic wastegate actuators and pulls ignition timing back to artificially limit torque ramp-up. Here is the hidden damage caused by this continuous electronic intervention. When the PCM artificially retards ignition timing while the turbochargers are building boost, it delays the combustion event inside the cylinder. Instead of the air-fuel mixture expanding rapidly and delivering its kinetic force against the top of the piston crown, the combustion flame front is still actively burning as the exhaust valves open. This sends a torrent of raw, unburned, 1,800 degrees Fahrenheit burning gas rushing directly out of the cylinder head ports and slamming into the exhaust manifolds and turbocharger turbine housings. This setting forces your exhaust manifolds to endure extreme thermal spikes under totally normal driving conditions. The cast iron exhaust manifolds on Ford's 3.5L EcoBoost engines are notoriously prone to severe warping and cracking due to this localized heat buildup. As the manifold violently expands and contracts from the late combustion heat spikes created by factory torque management, It exerts tremendous shear force on the outer manifold mounting studs. Eventually, the rear exhaust manifold studs snap completely off inside the cylinder head. You are left with an agonizing, high-pitched exhaust leak tick every morning, accompanied by a cabin filled with raw exhaust fumes. Repairing a snapped exhaust manifold stud on an EcoBoost requires pulling the entire wheel well liner, fighting rusted turbo hardware, and potentially extracting a hardened steel stud broken off flush inside an expensive aluminum cylinder head. A labor-intensive job that routinely costs between $1,500 and $2,800 per side. Even worse, that excessive thermal load is dumped directly into the turbine housing of your turbocharger and the upstream catalytic converters. Continuous exposure to unburned exhaust gases breaking down right at the converter face degrades the precious metal wash coats inside the catalytic substrate, causing premature catalytic converter breakdown and throwing persistent under-efficiency diagnostic trouble codes before your truck hits 90,000 miles. To counteract setting number 2, you must adjust how you request power from the engine and maintain your ignition system with extreme precision. Avoid lugging the engine, which means pushing the accelerator pedal down heavily while the transmission remains locked in a high gear at low RPM. Lugging forces the PCM to aggressively retard ignition timing and spike exhaust temperatures to manage knock while trying to build boost. If you need to accelerate or pass another vehicle, manually downshift a gear or two using the select shift toggle on your shifter before applying heavy throttle. This allows the engine to rev freely in its natural power band, reducing the PCM's need to pull ignition timing and dump raw flame into your exhaust manifolds. Furthermore, replace your spark plugs every 20,000 to 30,000 miles with high-grade iridium plugs, gapped precisely to 0.028 inches. A crisp, strong spark ensures complete combustion inside the cylinder chamber, preventing late burn cycles and keeping exhaust manifold temperatures hundreds of degrees cooler. We have pulled back the curtain on stop-start battery cycles, theoretical oil monitors, artificial oil pressure limits, and manifold warping torque management profiles. But nothing compares to the absolute mechanical destruction caused by the final factory configuration on our list. Setting number 1 is so deceptive that millions of truck and SUV owners actually think it is a beneficial, state-of-the-art protection feature designed to keep their engine operating smoothly, when in reality, it is cooking internal components, carbon-fouling intake valves, and setting up catastrophic engine failures before 100,000 miles. The factory gasoline direct injection, GDI, fuel mapping, paired with the closed-loop positive crankcase ventilation, PCV, logic. Ford markets their EcoBoost direct injection architecture as a masterpiece of power and efficiency, promising peak performance by spraying finely atomized fuel directly into the combustion chamber at pressures soaring up to 2,900 pounds per square inch. Here is the severe mechanical flaw that Ford's engineering department kept off the showroom floor window sticker. In traditional port-injected engines, fuel is sprayed directly onto the back of the intake valves. Gasoline naturally acts as a solvent, continuously washing away oil mist, unburned hydrocarbons, and blow-by carbon before it ever has a chance to bake onto the intake metal. But with Ford's direct injection factory mapping, fuel is injected straight into the cylinder bore, completely bypassing the intake valves entirely. At the exact same time, the factory PCV system setting pulls oily crankcase vapors directly out of the top of the valve covers and routes them straight back into the intake manifold to be reburned for emissions compliance. Without a continuous spray of cleansing gasoline to wash those intake valves clean, that hot, aerosolized oil mist slams directly into the blazing hot backsides of the intake valve stems. The extreme operating temperatures of a turbocharged engine instantly bake that oil mist onto the valve stems, turning it into a crusty, hardened, abrasive layer of carbon residue, a destructive phenomenon known as intake valve coking. Over thousands of miles, this carbon buildup grows exponentially, transforming from a thin film into thick, jagged deposits that restrict airflow into the cylinders, disrupt fluid aerodynamics, and prevent the intake valves from seating completely flat against the cylinder head valve seats. When an intake valve cannot seal flat due to heavy carbon coking,
Microscopic gaps remain open during the compression and power strokes. Superheated combustion gases blow backward past the unseated valve face at hypersonic speeds, burning the edge of the valve away like a plasma torch. I have pulled cylinder heads off 3.5-liter and 2.7-liter EcoBoost engines with less than 85,000 miles on the clock that had completely misfiring cylinders caused by burnt, pitted intake valves, all stemming directly from this unmitigated factory PCV setup. Replacing a burnt valve requires pulling the entire engine or removing the cab from the frame, running up a brutal repair bill that easily exceeds $4,000 to $5,000. Even worse, as those heavy carbon deposits break off in hard chunks, they travel down through the exhaust valves and enter the turbocharger turbine housing at over 100,000 revolutions per minute. A single chunk of hardened carbon striking the delicate, high-speed turbine blades causes instantaneous blade pitting, shaft unbalance, and total bearing destruction within seconds. The fix for setting number 1 is a mandatory 2-part mechanical defense strategy that every GDI Ford owner must implement immediately. First, install a high-efficiency dual-port oil catch can in line with your factory PCV system.
A quality catch can act as a mechanical condenser, trapping the heavy oil mist, moisture, and raw fuel vapors inside an aluminum reservoir before those contaminants can ever reach your intake manifold or coat your intake valves. You simply empty the reservoir every time you change your oil, removing up to half a quart of sticky black sludge that would have otherwise baked onto your engine's top end. Second, perform a professional intake valve cleaning service using specialized walnut shell blasting every 40,000 to 50,000 miles. Walnut shell blasting safely strips away hardened carbon deposits without scratching the intake ports or damaging the valve seats, restoring lost compression, eliminating rough idles, and protecting your turbocharger turbine wheels from catastrophic impact damage. Every single one of these 5 factory settings was designed around government mandates, warranty period calculations, and laboratory test cycles, not long-term mechanical durability in the real world. Your vehicle is an incredibly engineered machine, capable of delivering massive power and working hard for decades, but only if you take control of its maintenance away from factory defaults and corporate algorithms. By disabling auto start-stop on every drive, ignoring the factory oil life monitor in favor of strict 4,000-mile synthetic oil changes, manually overriding low oil pressure modes under load, preventing high heat lugging conditions, and installing an oil catch can to protect your intake valves, you effectively bypass the programmed obsolescence built into your vehicle's factory setup. None of these corrections require complex modifications or thousands of dollars in aftermarket upgrades. They simply require an informed owner who understands the physical reality under the hood. If this deep dive teardown gave you the actionable clarity you need to protect your vehicle and save thousands in unnecessary shop bills, make sure to hit that subscribe button, ring the notification bell, and leave a comment below letting me know which of these factory settings shocked you the most. Share this breakdown with every Ford owner you know who wants their vehicle to outlast the financing payments. Take care of your machine, drive smart, and I will see you on the next teardown.